Okay, so coming to the next part. Okay, this is the reverse of using the algebraic expression. So now we know our a plus b is due to when we expand it, right, it's a squared plus b squared. But what if we are given this equation? Are we able to get the factorized form back? Right, so from here we only need to look at the two terms at the end, a squared and b squared. So here x squared 9, they are perfect squares, right? So x squared is x times x. 9 will be 3 times 3. Right, so how do we know whether it's x plus 3 bracket square or x minus 9? Look at the two signs here. Right, so from here, x, if there are 2 plus, is x plus b. If it's 1 minus 1 plus, this is minus, right? So this is the only two identities you need to learn how to recognize. Okay, because the third one is quite obvious. You only have two terms and they must both be perfect squares. Okay, so again, moving on. Here is a perfect square, here is a perfect square. Both signs are plus. So I know it's y plus the square root of 16. Right, square root of 16 is 4. Right, so easy. Next one. Again, here is a perfect square, here is a perfect square. So 4z squared is actually 2z times 2z, right? Two same terms that multiply each other. I can express it as 2z bracket square. So this is a perfect square. So we should get 2z plus 1 square. Again, 49a square. Right, if you square root it, you will get 7a, right? Because 7a times 7a, right? Because 7a times 7a is 49a squared. Okay, so we will have 7a plus square root of 4, 2 squared. Okay, again, perfect square, you should be familiar with 25. So I get 5d plus 6 squared. And this one, again, will be p plus, okay, 16q squared will be 4q times 4q, right? 4q bracket square. Okay, so this is quite simple, right? You don't even need to look at the bottom, at the center. Okay, now we come to the minus. So as mentioned earlier, if your sign is minus plus, your algebraic expression is a minus b. So I look at it, perfect square, minus plus. So I will have a square root of 4 minus 2 square. Okay, moving on, m minus square root of 6 square. 25 square is 5c times 5c, right? So the square root is 5c plus, minus 1 square. Likewise from here, square root of 9 is 3s minus square root of 16, 4 square. Here, s square t square, st bracket square. So you will get st. Okay, this will be 48, 56, 61 minus 8 bracket square. And this one will be 9x squared is 3x times 3x. Okay, so we get 3x minus, again, this one square root will be 8y squared. Okay, so far quite simple. Now the last part, again, square root of a, square root of 9. This, they are both perfect square. Your sign here is a minus. So going back to your identities, there is only one answer, which is this. When a perfect square minus a perfect square, you can factorize into a plus b, a minus b. Okay, so from here, perfect square minus perfect square, a minus 3, a plus 3. 49b square, okay, by now should be familiar. Square root of 49 is 7. b, 1 square minus 1 plus 1. Okay, next one. Factorize, we get 6c minus 5d. 6c plus 5d. Okay, square root 36 is 6, square root 25 is 5. Okay, simple. Square root 4 is 2, so 2m. Square root 1 to 1 is 11, minus 11n. 2m plus 11n. Right, next one. Okay, you realize they're not square root, but they have a common factor, which is probably 2. I get 9u squared minus 25v squared, and voila, I have two perfect squares. They minus each other, so I factorize. Square root of 9 is 3u, minus square root of 25 is 5v, 3u plus 5v. Okay, again this one, common factor is 5, so you get 9x squared minus 64y squared. Again, perfect square of 9 is 3, perfect square of 64 is minus 8y, 3x plus 8y. Okay, and then you'll get your answer. Okay, so how do we use it to find the value of the following without using a calculator? Okay, again, perfect square minus perfect square, so we have 143 minus 142, 143 plus 142, so we will get 1 times 582 285. Okay, next one, same thing, concept is the same. 397 minus 387, 397 plus 387. Right, so 397 is 10. This one, very quickly, 397 784. Answer 7840. Okay, after that, this is 685 minus 315. 685 plus 315. Okay, so from here we will get not supposed to use calculator, but when you say without using calculator, it just means you need to show full working, right? So 1000, right? Okay, next one, 13.5 plus 6.5, 13.5 minus 6.5, 0, 20, 5, 7, 1400. Okay, last two, 98 minus square root of 4 is 2, 98 square root of 4 is 2, so it's 9600, 9600. Okay, the last one, we have 200.5 plus 199.5, 200.5 minus 199.5. Okay, so this will add up to 400 multiplied by 1. Alright, so square root of 400, if you are not too sure, is 20. Right, so pretty simple. Okay, next one. Okay, so if you look at this, it's obvious that you have to factorize out the common terms first. 2x squared minus 6x plus 9. 2. Right, so again, look at the sign. Minus plus perfect square. So we get x minus 3 square. Next one, take out 5. 9m squared plus 12mn plus 4n squared. Okay, again, notice plus perfect square. So 5, 3m plus 2n bracket square. This one, factorize out the 2. 9 minus 25p squared. Notice only two terms, perfect square. 2, 3 plus 5p, 3 minus 5p. Okay, this one, common factor y. X squared minus 22x plus 1 to 1. Again, 1 plus 1 minus. Alright, perfect square. Y. X plus 11, x minus 11. And lastly, right, common factor a. 9a squared minus 12a plus 4b squared. Take note, minus plus. Oh, sorry. Did this too fast. This should be minus 11 squared. Okay, so moving on. A 3a minus 2b squared. Okay. Next one, factorize out 3x. Okay, factorize out 3x. You get x squared minus 1, 6. 3x. X minus 4, x plus 4. Okay, moving on to question 6. Okay, now from here you will realize that you have to take this as one term. Say for example, let a equals to x plus y. So I can write this as a squared minus 49, and then it becomes your difference of square, right? So I become a minus 7, a plus 7. But don't forget a is x plus y, so I get back x plus y minus 7, x plus y plus 7. Okay, so same thing here. If this is a single term, I split it apart. I get u minus v. One is a plus, square root of 25 is 5. One is a minus, square root of 5. 25 is 5. Okay, next one. Now this one is double term. So like this whole term is a squared, this whole term is b squared. So I will get a plus 3b plus 3a plus b. Right, so this is your a plus b. So it's going to be a very long equation. And then you will have to write in your a minus b. So Okay, let me squeeze it in a bit. A plus 3b plus 3a plus b. Okay, so this is your a plus b. Now we want our a minus b, so it's a plus 3b minus 3a plus b. Okay, take note, I haven't opened up the brackets yet. So a plus 3b plus 3a plus b, a plus 3b minus 3a minus b. Okay, remember, open up the brackets. So 4a plus 4b minus 2a plus 2b. Okay, now we can still factorize some more because they have common factor 2, common factor 4. So I take out the 4, I take out the 2. So 2 times 4 is 8. A plus b minus a plus b. Okay, next one. It gets more and more complicated. So the square root of 169 is 13 square, right? And this will be 6 square. So you will have to take this whole thing as your a square, and this whole thing as your b square, right? So it is rewritten as 6 bracket m plus n bracket square minus 13 square. Right, so your a plus b will be 6 bracket m plus n minus 13. And your a minus b, 6m plus n plus 13. Okay, expand again. 6m plus 6n minus 13. 6m plus 6n plus 13. Okay. Hopefully you're able to understand so far. Okay, for each of the following expression, find the number k such that the given expression is a perfect square. Okay, so this will be challenging because we need to use the center number to find k, right? So remember your center number is 2ab, right? So from here we know our a is 10, so it's 2bx equals to 10x, right? So 2b equals to 10, right? So our b equals to 5, which means that k equals to 5 square, because k is b square, right? So because k is b square, we get 5 square 25. Next one. Our 4x, right, means we can convert it into 2x squared, right, because we expand. This means that our a is 2x. So 2ab equals to 24x, which is 2 bracket 2x bracket b 24x. So b equals to 24x divided by 4x, which is 6. So our k equals to b squared, which is 6 squared, 36. Okay. From here, now we start with b. This is 7 squared. So we know that b equals to 7. Right, b squared equals to 49, b equals to 7. So again, 2ab equals to 28y. So now our b is 7, so 7 times 2, 14a. our a is 2y. Right, 28 divided by 14, 2y. So k a square equals to 2y bracket square 4y square. So take note, k doesn't involve y, so k equals to 4. And then the last one, we know this is z. Okay, we want to find the second one, right? So we know that a equals to z. This one, square root is b square, 1 to 1, b equals to 11. So k z equals to 2ab. 2 times a is z, b is 11. So we get z. So we get 22z equals to kz. Right, so z we know, or k we compare is 22. Okay, so hopefully this helps. Any questions, please ask.